Okay, everybody, so we are going to look at how to graph quadratics using the graphing calculator. So the first thing we have to do, remember, is you have to make it equal to 0. So the first equation that we have in our notes is 2x squared minus 7x equals 4. And to get this ready, I'm going to make it equal to 0. So I'm going to start by subtracting 4 from both sides. When I do that, that'll leave me with the equation 2x squared minus 7x minus 4 equals 0. Remember in the notes it said to make that equation 2x squared minus 7x minus 4 equals y. So we're going to replace the 0 with y. And then we're going to go ahead and enter it into our graphing calculator. So this is a TI-84 plus color edition. Really any TI 83, 84, the steps will be the same. The view that you have might be a little bit different depending on the version, but the steps remain relatively the same, and you'll still see the same results. See if I can focus a little bit better. Okay, so now we're going to turn on the calculator, hit the on button, and to graph it, you're always going to go up to this top row, use the y equals button. And in there, you'll have y1, y2, y3. Those are just different graphs. You can plot multiple graphs at a time. If you have any graphs in there already, you want to clear those out. And now I'm going to type in my equation. So I'm going to do my 2. And then the variable x is right next to that green alpha button. So you press that and you'll see the x appear. For x squared, we can press the x squared button right here, and that'll put the x squared there. Then we'll do minus 7, and again, I'll put another x in there, and then minus 4. And then you do want to graph this. Before you do that, you want to check your window just to see what it is. Now, my window is a little bit different than the standard window. And I'm going to show you what the standard window is in a second. Let me show you how to get to the standard window without typing everything in here. What you want to do is press zoom, and then number 6, it says zoom standard. It may be a different number on yours, but I think it's pretty much consistently 6 on everyone. All right, so I did zoom 6, and then it goes automatically to my graph. But let me show you. There's my window. So it says x min is -10, x max is 10, my x scale, so it's counting by ones, is 1, y min -10, x y max is 10, and the y scale is 1. So that would be your standard window that you want to use there. And then once you have that standard window in there and you want to get to the graph, press the graph. Now, I do apologize, my calculator, it's a little hard to see, but if you have it graphed as well, you should be able to see it nicely. So, but if we look, and I can't really make it focus too terribly good there. Let me maybe turn down the brightness. There we go. That makes it a little bit easier to see. Okay. So what we're looking for here on our graph is where our graph crosses over that x-axis. That is our solutions to our equations. That is what x will equal. So we are going to now, I know in the notes it says to use the trace key, which you can use, or right here we can kind of preview and see. I do see this first line of the parabola is crossing over at 1, 2, 3, x equals 4. So I'm going to put that there. And then it looks like for the other one, it's halfway between 0 and -1. So I'm going to say x equals -5/10. And again, when you're looking at a graph, it's really an estimation of the answer, not always exact, because our graphs aren't always going to cross over perfect numbers. You can, like I said before, use the trace button. And let me clear that out for a second. I'm going to go back to my graph, hit the trace button, and you can use the left or right arrows to kind of see that cursor move along, and you can see wherever it stops, like there's the x value, there's the y value. So if I want to try to get it close, I'm going to go down a little bit. It's not quite perfect. So, the trace button is a little hard to do. So the ones we're going to do, you can just look at it and review and see what it is. So let's take a look at our second problem and do that one real quick. That one was, we have on our paper 4x squared plus 1 equals 3x. And we are going to make it equal to 0. So I'm going to subtract 3x from both sides. And that will give me 4x squared minus 3x plus 1 equals 0. Or we know we need it to be equal to y. So 4x squared minus 3x plus 1 equals y. I'm going to go ahead and graph that. So I'm going to look at my y equals. I'm going to go up there. I'm going to clear the equation that was in there. All right, press the clear button right here. And now let's type in our 4, and then we'll go up to our x, use our x squared button right here, minus 3x plus 1. And then I can hit graph because I know my window should be in the standard window. All right, now when we look at this, you can tell if you look at it carefully, and I don't know if I can make it come up there any higher. I can a little bit. All right, let's see here. Let's focus. So if you look here, we are looking for where our parabola crosses over the x-axis to find our answer. Does this graph cross over the x-axis? And remember that x-axis is the axis right here. So it does not. So that means that if we were to find the discriminant of this equation, it would have two non-real answers. So they wouldn't be real numbers. It would be a negative discriminant. So for our answer here, because it doesn't cross over the x-axis, we are going to put no real solution because it does not cross over that x-axis. Okay, now we're going to take a look at our third example. And for this one, we are going to find where the graph crosses over the x-axis again. So we want to make it equal to 0. So I'm going to start off by adding 12 to both sides. So I'm going to end up with 3x squared plus 12x plus 12 equals 0. Or again, we're going to make it equals y. So we know that's where we it makes it easier to graph. We know we go to that y equals button. You can do it on paper. You don't have to. So I'm going to go to y equals. I'll clear out the equation that's there. And then I'm going to put in my 3x squared plus 12x plus 12. And then I'll go to my graph button. All right, now we look at this one. And this one, it's a little hard to see, but if you look at that, and let me pull it up here and focus it in a little bit. All right, now this one, it does hit that x-axis, barely, but it does. And it looks like if we look at that, where it hits that x-axis, it's just going to be the vertex, and it is at -2 on that x-axis. So we are going to say, for this one, that x equals a -2. So if we were to do the discriminant here, I think we would find that the discriminant is equal to 0, and there's one real solution. And you can double check that and look at that. Let's graph our final problem, which is 3x squared plus 8x minus 11 equals 13 minus 6x. So now I'm going to make it equal to 0. I'm going to subtract 13 from both sides. And then I'm going to add 6x to both sides. So that gives me 3x squared plus 14x minus 24 equals 0 or equals y. And we'll go ahead and graph it. So we're going to do 3 x squared plus 14x minus 24. I'll hit graph. Now for this one, we don't see the entire graph on there. We just see part of it. We can see the parabola. We know that that parabola is there, and we can find the answer. We don't need to see the vertex necessarily, so it's okay. We can get our answer from this. If we look at this graph, I can tell that it crosses over the x-axis at -1, -2, -3, -4, -5, -6, and then a little bit after 1. So it's between 1 and 2, not quite 1.5, I don't think. So I'm going to estimate 1.3. And again, when we write our answers here, it is just an estimate. It's not always exact. So I'm going to say x equals -6 and 1.3. And again, that's an estimate. It's not an exact answer. When we're looking at graphs, to find the x intercepts, it's always going to be an approximate answer. It's never going to be exact because we can't always be sure just by looking at the graph. That's what factoring and the quadratic formula do. They give us an exact answer, but graphing will give us an approximate answer. And I hope that helps you with graphing those using the graphing calculators and finding the x-intercepts with a quadratic equation.